We're going to use the difference of quotients to find the slope. And this will come in when you start finding derivatives. It's going to give you either an equation or a number, so it depends on what part of the line you're focusing on. So let me just show you how to use the formula. This part of the formula says I'm taking the function, and everywhere I see an x, I'm going to replace it with x plus h. So 6 minus 6, instead of x, I'm going to put an x plus h. This part says I'm going to subtract the function, which is 6 minus 6x. I highly recommend using parentheses right here so that you make sure you distribute that negative. All right, so let's clean up the top. 6, distribute minus 6x, minus 6h, minus 6 plus 6x. So the whole thing's over h, so let's do some canceling here. This 6 and negative 6, negative 6x and positive 6x. So I'm left with negative 6h over h. When we cancel the h's, my slope is negative 6. But hopefully you looked at this and noticed it was a straight line, and therefore your slope is what's attached to x. Let's look at another one. Again, the first piece, I'm going to replace every x with x plus h. Then I'm going to subtract the function, and the whole thing is over h. So this first part is x plus h times x plus h. When I distribute that out, I get x squared plus 2hx plus h squared. Let's distribute that. Minus 3x, minus 3h, minus x squared, minus 3x. The entire thing over h. Let's do some canceling. That will cancel with that. I found a mistake right here. That should be a minus, which means this should be a plus. So this will cancel with this. And in the numerator, it looks like we have 2hx plus h squared minus 3h all over h. Well, let's go ahead and factor out something that we have in common. And in common, we have an h on the top. So if I factor out an h, I'm left with 2x plus h squared, if I factor out an h plus h minus 3 all over h. So therefore, those cancel. Now, the last thing I need to do is, because I still have an h, I want to evaluate the limit when h is 0. So I'm going to make this a 0, so therefore I can evaluate, and it's 2x minus 3.